what I had asked everybody to do, the lesson ran a little long, so I asked everybody to complete the graph and the rest of this example. So I've got it up here. And then, well, not the rest of the example because there's another part that you don't know how to do, I think part D, that we'll get to. And then you're going to be doing a lab today, and your assignment today will be to complete the lab report, which I think the lab report will be due like Tuesday or Wednesday of next week. But also I'm going to want you doing the assigned problems attached to this lesson. There's 4 or 5 questions where you have to find slopes, to find speeds, and that kind of thing. So the first thing is you plot all of the points. The first thing is you plot the points, and that's where my points are. I'll admit this morning I thought, well, I should put this together. I didn't spend a lot of time with it, but that should look fairly familiar. I think the challenge of drawing what we call the line of best fit here is quite simple in this question, because those data points are almost perfectly in line with each other. And then you have to pick 2 points. Now, just as the bell rang yesterday and you were leaving, there was something that popped into my head that I thought, I should have said this earlier. Ignore the origin when you draw your line of best fit. It's why I don't even plot 0, 0. It's a meaningless data point. There may be reasons, everybody. There may be reasons in a lab, in a situation where measurements are made, where this is what your data looks like. There could be reasons for that. And I hope you would agree that the line I've drawn is the line of best fit. It represents the data, right? Does it go through the origin? No, and it shouldn't. Because maybe there was some systematic error with whatever I was using to measure the time, and it was measuring all of the times bigger than they should have been. But that doesn't change the speed. The speed will still be the slope of that line. So you ignore the origin when you draw the line of best fit. As well, I'm going to go one step further here and tell you, even if your line, if you ignore the origin and you draw your line of best fit and you look and it happens to go through the origin, you're never allowed to use the origin to find the slope. You're not allowed to do that. You need to construct a triangle on this graph by picking 2 points on the line that are readable, nicely readable. That makes it easier for you. That are reasonably far apart, and that are not data points. You're not allowed to choose data points. So I'm choosing these 2 points that I've put little blue lines on. Those are the points that I chose. And the scale vertically, I'm confident that you understand how to read the scale, but at the same time, I'm hesitant in just assuming that everybody knows how to read the scale. It's part of my job is to make sure that everybody knows what's going on. So if we take a look at this scale vertically, I'll start off with vertically. The scale that I've provided for you, I believe, has 1 here, right? 1 centimeter. Yes? Okay. Well, there's 5 squares. So, you know, the way my brain works is I say, well, if it were 10, it would be 2, 4, 6, 8, 10. So since it's 1, it's 0.2, 0.4, 0.6, etc. So this is 0.2, and then 0.4. This is 0.2, and then 0.4, 0.6, 0.8, and 1. The same thing goes here. If this is 0.1, and it's gotten faded out because I've blown it up. If this is 0.1, this would be 0.02, 0.04, 0.06, 0.08, 0.1. So anyway, these are my 2 data points. So now when I find the slope, my slope, which will be my velocity, is going to be 7.6 minus 0.4, and this will be in centimeters, over my run is 0.62 minus 0.04, and this is in seconds. So what do I get? I think you were saying you're getting 12.4. Yeah, let's see. Why does everything keep moving over to my other screen? Give me a second. I did the calculation this morning, but I don't, for some reason 12.2 was sticking in my head, but maybe I'm wrong. So I'm going to take 7.2, which is the numerator. I mean, you can subtract those numbers if you want. I know what it is. 7.2 divided by 0.58. And again, you can subtract them. So 12.4. An interesting thing is I went on and on yesterday about having 2 decimal places in our numbers. I hope you understood that when you plotted the points, you couldn't read to the second decimal place. You were basically rounding to the nearest tenth. Have you found what happened? Okay, so I'm going to come back to you in a little bit, okay? We'll worry about it later. We'll be able to fix it, whatever it is, okay? I want to, though, right now, have us take a look at number 4. So what we want to do is use our graphing calculator to perform what's called a linear regression of the data to find the velocity of the object. So there's a lot going on here. I'm interested in this data. I'll just do this. And I do not, this is important as well. When you do a linear regression, you do not want to put in 0, 0. Don't. Do you agree that 0, 0 is not even a measurement? I hope. Nobody measured that. You're just saying, well, it starts at the beginning. That's all you're saying. So what we're going to do to begin with is enter this data into our statistics tables. And I'm going to go out on a limb and say none of you have ever done this before. Okay. So there's a button on your calculator that says stat. And it means statistics. So you go stat. And we want to edit. And what you will have in here are a number of lists. Across the top, you should see L1, L2, L3, and I think it goes up to L4, 5, 6 if you scroll over. Okay. So my first question to you is there anybody who's missing lists, namely L1 and L2? Is there anybody who you do not have an L1 or an L2? Okay. Is there anybody who, like my calculator is in right now, is there anybody who has numbers in your lists already? Okay, well, you're going to put numbers in, and then later you're going to want to get rid of them. Okay? So how do you get rid of the numbers in the list? You know where you go to reset your calculator memory, which is second plus. If you go to second plus, there's an option that says clear all lists. So if I choose that, it's going to kick me out into the home screen, and I hit enter and it's done. But now when I go stat edit, they're empty. So here's what you want to remember. L1 is for your independent or manipulated variable. L1 is for your x. It's for the thing that goes on the horizontal axis. So the first thing we're going to do is go over to L1 and start entering in the data. 0.1, 0.2, 0.3. And every time you enter a data point, you hit enter. And you want to double check because your calculator will be scrolling and you'll miss stuff, right? Like it'll go up. You want to just scroll up and make sure that everything is entered correctly. .39, 3.6. And again, you want to just double check things as you're entering them, make sure it's all entered correctly. And obviously, well, it's obvious to me, I hope it's obvious to you, the orders of these are important, right? You can't put the times in and then just randomly sort your distances because they're ordered pairs. They lock together a certain time with a certain distance. So I always like to just scroll up and make sure that everything is copacetic here. Whoops, wrong calculator. 8.6, 7.38, 6.13, 4.88, 3.6. I think we're okay. So now I could just get to it and tell you what we do to find the slope. But I want to take the opportunity to teach something else to you. I think many of you will go on to post-secondary and take science at some level, and you will be doing lab work. And what a regression is, don't forget, we're doing what's called a regression. It says do a linear regression. What a regression is a way to take data from an experiment and connect it mathematically to a formula, to an equation. Okay? And if the data falls in a straight line, you would do a linear regression. If the data falls in a parabolic shape, you would do what's called a quadratic regression. I'm just curious, is there anybody who has completed Math 20-1? Okay, so you're familiar with the concept of a parabola. If you looked at your data in a lab and it looked like a parabolic shape, then you wouldn't do a linear regression, you would do a quadratic. If it looked like something else, you'd do a different regression. So you don't need to do this because you know it's linear, but I want to show you what your calculator is capable of. Go into y equals and make sure that you don't have anything in there. Okay? So if there's stuff in there, clear it out. Because what we want to do is graph this data. This graph that we constructed here, we want to be able to see it. You don't have to, but it's nice to. So how do we do that? Well, it's not a function that we're graphing, it's a plot of data. And if you look, when you go y equals, if you go second y, you get into a different region. It's called stat plot. And right now it says plot 1 is off, plot 2 is off, plot 3 is off, etc. But if I go into this by hitting enter, I can turn plot 1 on. Okay. And by the way, if you look, the defaults here are the type of plot we want is just a bunch of dots. X list is L1, Y list is L2, and I prefer to plot a little square. If you plot a dot like this option, then sometimes you won't see it because it's too small or it's right on a grid line or an axis or something. So I prefer that. By the way, just quit out of here. I'm just familiarizing you with your calculator. Go to y equals now. You can see that plot 1 is highlighted because you've turned it on. So we didn't have to go in there to turn it on. Because when we went into y earlier, it looked like that. I can just scroll up and hit enter to turn it on. The only problem with that is I don't get a chance to make sure everything else is set properly. Okay? So now there's one other thing, because if I do graph now, there's no guarantee I see one data point. Why is that? Well, because I've been fiddling around with this in another class and I've changed my window settings. And normally in math, some of you are in Math 20. Who's in Math 20-1 right now? Okay. Normally in math, to change the window settings, you go zoom. You go zoom standard, zoom in, zoom out. That's a nightmare. We want to instead choose window and set the window settings. Look at our graph. Or look at our data. We want to go up to 0.8 seconds. So let's go up to 1 second. Our minimum time will be 0. Our maximum time will be 1. I'm saying go from 0 to 1 on the horizontal axis. Does anybody know what that X scale does? It's going to be where the ticks are. So if I go X scale 0.1, then on my graph I'm going to see a tick at 0.1, 0.2, 0.3. It's not, who cares what it is? But it's nice to have it set up that way. Now what about my Y? Well, my biggest Y is 9.8, so maybe I should just go up to 10. Go from 0 to 10. And maybe up by 2. 0 to 10. up by 2. Oh, man. Give me a second. Okay, so we're going to go from 0 to 1 up by 0.1. We're going to go from 0 to 10 up by maybe 2. Never change anything else. You can play around with it and see what's going to happen. The resolution, if you change that number, then you'll get less detail in graphs, and it's just leave it alone. So now, when I hit graph, see there are my ticks that I was talking about? So, you do not need to do all of this that I've just done to answer question 4. But if we're going to do a linear regression and you were, say, in post-secondary, you would have to convince yourself that it is, in fact, linear. Because then you say, oh, okay, the type of regression I'm going to do is linear. Is there anybody who is not getting this? Yep. What's happening? Are you getting an error?
No, it's just blank.
Your plot is off. So you see how it says off,
Yeah.
second Y. Go in there, hit enter.
Okay.
Gotcha. Good? Yeah, okay. So that was the error I thought that her calculator was going to throw at us. If you see an error that says DIM mismatch, that means dimension mismatch, and that will happen if you have a different number. I will show you here on mine. Stat edit. It will happen if you have a different number of data in one list than the other. Okay. So if I were to go graph right now, I get that. And it's dimensions because X and Y are dimensions and they're not matching. So just go back to stat edit and see if there's something else in there. Or you've misaligned them. Is that what's happened? Okay. Yeah, and I was going to do that too because I was going to go 0.1, 0.2, 0.3, and then I looked quickly and I saw we ended at 0.8. So I'm going to stat edit, delete that out. All right. So now what we're going to do is a linear regression. You've done all of this work. The main part is you've put your data into the lists. You've done all of this work. You've convinced yourself that there's the graph, which is nice, right? We don't have to. This thing that we're looking at on paper, we can look at it on here instead. It's the same graph. I mean, it looks angled different because my calculator screen is rectangular, and there's a different way of doing things. So now we want to do a linear regression because we know it's linear. So you go back to your stat and you go over to calculate. And it says linear regression. Now, if I'm about to find out something that I think is important. If I choose linear regression on this calculator, this is what I see. How many of you see that? How many of you see just this? Okay, so we don't have to worry about it then. I'm not going to worry about that. So this, you have to bump through all of these to confirm all of your choices before you commit. So is the X list L1? Yes. If it's not, we could change it. Maybe you put X under L3, and there's an L3 down here. The second function of the number 3. So I could go, it's not going to be able to do anything because there's nothing in L3, but maybe I have X in L3. There's reasons why you might do that. So we can confirm it's L1, it's L2. Don't do anything with the frequency. We'll talk about storing the equation in a second, but in the meantime, I'm just going to go calculate, and it gives me this information. And this is a Math 10 equation. It's a linear equation. In Math 10, we would write y equals mx plus b. In your calculator, it uses ax plus b. Live with it. It's just a letter. Okay? A is the slope, b is the y-intercept. And it's telling you that in this particular set of data, y is equal to 12.40x plus negative 0.087. So the fact that this is not 0, that the y-intercept is not 0, means my graph doesn't go exactly through the origin. And that's fine, because I don't care about that. What do I care about? I care about the fact that this, which is the slope, is equal to the velocity in this analysis. And I've answered the question. Without making a physical graph, I've answered the question. So, to summarize, you put your data in stat edit. You go stat calc and you do a linear regression. You don't need to look at the graph, but it's nice to see the graph. I want to show you one final thing here, because we know that the line we drew matches the data because we can see it, right? How do we know, how can we trust the calculator? How can we convince ourselves that the calculator has done a good job? Well, let me do the linear regression again. But where it says store, that means regression equation, I'm going to tell the calculator to put it in. I'll use my other calculator to show you. I'm going to tell the calculator to put it in here. So I'm just using this calculator on the right to illustrate what I want to do. I want to take the equation that it gets and I want to pop it in here. And that's Y1. And if you look, there's a vars button, stands for variables. And if I choose it and go over to Y variables and choose function, there are all my functions. So I can go Y1. Now watch what happens when I go calculate. It gives me the equation, and if I go to Y1, I got the equation in there. I mean, I could have written it down and typed it in there, but the whole equation is there. And the beautiful thing now is, if I go to graph, I can see that it's fitting perfectly. It's done a really good job. Not necessary. None of it is. Put your data in your lists, do a linear regression. You find the slope that way.